Hello everyone, welcome back to PR with Mike. We'll be discussing about merging and splitting our data sets in this video. Once again, if this project reminds you of a problem you've solved or a project you are working on, or if you need some insights or some explanations or some questions, you can drop a comment in the comment section. So since we have to speed things up, I have annotated 5 batches 1 to 5. And the next step for us now is we need to go into our manifest.json and update the ones that I have annotated. So batch 5. Then after that, then we have to create a new script to merge our annotations. So this script is what we are going to use to merge our annotations and also to ensure that we truly have the annotations that we specified. And one important reason, like we've been discussing so far, is that since we batched our data for the annotators, for example, to annotate it, we then have to batch the annotations, or to actually merge actually. We then have to merge the annotations, and when we merge the annotations, we can then proceed to split our data sets and generate the corresponding YAML file. So let's get to that. And one other important insight is that merging our annotations is a very important step to ensure you do not lose any data, and you do not, how would I call it, you do not create problems in your annotations. So we then have to import JSON, then import shorttail. We have to import part 2. Import parts. We have to specify our project root. Let's fetch that from this. Yeah. And let's fetch this to make our to help us go faster. So we then have to define our batches. Our batches is in project root data, then batches. And we need to define a pool. Our image, since we are merging our annotations, we have to merge the images too. So we have to define pool folders for our annotations and our images. Our annotation images and labels rather. So pool image is project root data annotated. Let's have that in an annotated folder. Then images, we also need to have pool label. Pool label. Which we then have this as labels. So we then proceed. We have to define our main function, manifest parts, is our project root. Then it's not in our project, it's in our batches actually. Batches manifest.json batches. We also have to verify if we have our manifest. If not manifest parts, then we have to raise a system exit manifest part does not exist. Manifest data rather. Manifest data does not exist. Okay, so we then have to proceed to say we need to create our pool images directory and pool labels directory. They'll make their parent is equal to true, exist okay is equal to true as usual. So we have to do the same for our pool label directory. So the next step is we then have to load our manifest data. Manifest is equal to json.loads, then manifest paths.read text. So we proceed by keeping track of our match data set, which we have to create a variable for it. Missing labels. To keep track of images with missing labels is equal to 0. Then I have to go through our data for batch name info in manifest.items. We then have to, if not info.get annotation, we have to confirm that the annotations for that is set to true by us. .get annotations print skipping batch name not yet annotated, then continue. Then I have to proceed. Then I have to define the image directory for that batch. Image directory is equal to batches, then batch name, images, define labels. We have to define the labels directory for it too, for that batch that we have annotated. So that will be our label directory. Then we proceed for image in sorted. Let's check our manifest. We want to go through the images for each batch. So where's our match annotations? In sorted image dar.glob to get all the JPG and JPEGs in there. .jpg plus the one for JPEG and PNG. So let's just copy and paste. Okay, so update this for JPEG and update this for PNG. Okay, so we then proceed to say label. We then have to check if the label for that corresponding image exists. Label directory plus yes, then image.stem to get the image name plus .txt so that we can check if that annotation for that image exists. Then show tail the copy the image to the image pool. We then have to keep track of the image name. Let me create space there. Image the name. Okay, so since we've copied the image, we then have to check if the label exists. .exists, yes. Then we then have to do the same thing, but for the label pool now. So, but this one will now be same thing, but we are changing this to label. We're not doing lbl the name in this instance. So else, but we have to increase the merge to confirm that this exists. If the image does not exist, if the label does not exist, we then have to do missing labels plus equals 1. Then we have to print warning image the name in batch name has no matching label for when an image does not have a matching label. Okay, we then have to proceed outside the loop to confirm that it is done merging. Print merged. We have to check our amount of merged images. Labeled images into full image the parents. So we then have to keep track of if they are missing. If missing labels, print warning again. So actually we don't want to copy the images if the labels does not exist. So let's proceed. Warning some missing images. Let's just do missing labels. Does not exist and has been excluded from image pool. So the reason for this is if we have missing labels for some particular images, we end up not copying those images into our pool so that we do not have corrupted data during splits or training. So if name equals main, then we then have to execute our main function. So let's try this now. Okay, so let's try this now. So we then have to call our merge annotations. Okay, so it tells us that it's ignored every images. We don't have images and labels. But let's check our manifest. We have annotated sets to true for our first 5 batches. However, we do not have those. So if not info.get annotations. So I think there is an issue. Annotated, not annotations. So that's a bug. Let's fix that bug. Okay, so let's run our code once again. So module object is not callable. So shorttail.copy. That was another bug. So let's. Okay, so as you can see now, we now have our images here and our labels here. And it says 1-in-1 does not exist and has been excluded from image pool. Okay, so our next step now is we have to shuffle before splitting. So, and the reason why I have to shuffle before splitting is so that we have random data during training and they are not skewed. So without shuffling, the train sets, for example, the first 35 images, or let's say in our case now, we have about 24 images. They might be mostly apple or banana batches. So if we just focused on only those, the model might see only mango origin training, which is an obvious failure. So which is why we are going to set a random seed of 42 before shuffling. You can set any number. So anyone who clones the repo and runs the scripts eventually should get the same exact train tests validation splits. So this is very important because it is production standard and reproducibility is not optional in machine learning pipelines. So let's proceed to our split data sets. Shuffle and split data sets, but let's call it our split data set.py. So let's import random, but let's make this easier. Let's just copy some of our imports from here. So let's also import random. So we have to let's also copy this for us to reuse here. So we need project root, we also need pool, and we need out. So pool is equal to project root, which is our annotated, where we have our images and labels. So we also need outputs, which is going to be our processed directory for train test validation. Out is equal to, let's then replace this with processed. Okay, so let's define our defaults. Dataset splits configuration. So it is standard in machine learning when you are splitting your data that you have 70% of your data for training, 20% of your data for validation, and like 10% for testing. However, some researchers, some scientists also recommend that you can use 70% for training, 15 for validation, and 15 for testing. So let's define that. Train split is equal to 0.7, which is 70%. Validation split which is equal to 0.2, which is 20%, and test split, which is equal to 0.1, which is 10%. Let's leave that. So then we then have to define our main function. So main, we then have to assert, so that we can be sure that our all this sums up to 1. Very important. Assert that absolute of what? Train splits plus validation splits plus test splits minus 1, or let's just say yes, 1.0 is less than it, because it is less than 1 to the exponent of minus 6. If not, just say this is wrong. Split must sum up to 1.0. So let's try this to confirm. So if name equals main, just run our main function. So let's run our split data sets to confirm that they all sum up to 1. The pi. Okay, so let's try something. Let me add 0.11 so that we can see this. Can you see? Split must sum up to 1. So that is a very, very important step. So then let's start our splitting as long as the assert passes or can pass. So let's indent this. So we then say images is equal to, let me just fetch this to make it easier. Okay, let's just get this. And sum it up. Okay, so we can proceed. If not images, just raise a system exit, and say no images found in where? In annotated pool of data. So if we have images, then let's proceed. Random seed, let's create a random seed variable here. Random seed is equal to 42. Random the seed is what? Random seed. Then let's shuffle this. Random the shuffle. Let's shuffle our images randomly. Okay, so then let's start our splitting. N is what? The length of images. Then train cut. Train cut is what? Int of what? N times train splits. So we need to get the amount of images for train. Then val cut is equal to int of what? N times train plus train splits plus val splits. Okay, so let's print this so that we can see what value that gives us. Train cut is what? Train cut validation cut is what? Validation cut. So let's run this. Let's correct this back to 0.1. Oh, okay, so this should not be this. This should be pool, our pool instead. Pool, then images, let's have this and let's replace it for the rest. That was a bug that we had to fix. Place for this to okay, so let's run this. As you can see, we have our train cut, we have our validation cut, and let's proceed. So let's just comment this out for now. So let's now have our split. Split is what? Train. Let's get our train images. Train cuts. Let's have our validation. Images. Train cuts. To validation cuts. That was wrong. Let's fix this. Okay, so then let's have our tests is what? Images, then the rest from the validation cuts. Okay, so let's now start our copying process to train test validation. So for split name, split images in split dot items out, we have to create our directory for our processed dot split plus split name, then images dot make directory. Let's copy this from here so we don't have to write all that. Okay, so let's also do for the labels. Yes, so let's now have a variable to check for the ones that we are going to skip. So for image in split images, yes, okay, we then have to do label is equal to pool labels, then we have to get the label name, image dot stem, then dot txt. So that's our label Then have to run our short tail dot copy, then our image, our output directory, then plus our split name, which is train or test or validation, whichever it is, then images, then image dot name. So we don't have to do if label exists, but just as an extra precaution, if label dot exists, let's also copy our label as an extra validation, although we should be sure of the labels and images we have from our last image annotations. So this is going to be labels, and this will be label.name. So else just increment skipped plus equals 1. So if skipped, since this should cover the entire loop, if skipped, we should not have anything in skipped actually, but print vanilla skipped images in split name. But this should actually be inside the loop, yes. So we are notifying ourselves that does not have label. Okay, so let's print the final status of our splits. So we then say dataset written to our output directory. Okay, so we had this from our last one. Let's delete it so that we can see it be created in real time. Okay, I forgot a comma. There is a bug. Here is it, line 34. Oh, okay, there is no colon here for this dictionary. Okay, so let's clear this terminal. Okay, there is another bug. Images. Okay. Oh wow. Okay, another bug. So for us to copy our images, oh, this should be this and this should be this. So let's run it once again. As you can see, we now have our data here in processed, images, labels, train, images, labels, validation. Again, this data is too small for us to train with. We'll be training with the entire data, but this is just to put us through the process of when you have raw data that is not annotated, and you have to go through the annotation processes, and you have to ensure that it's annotated and prepared for you to train your model. So the last step for us now before training is to generate our YAML file, which is also an important step. So let's have another script here. Generate YAML.py rather. import sys from pathlib import path import YAML, and let's also ensure we have this in place. I think it's sample data sets. Okay, so we need to have this in place so we can. Okay, so we now have to import the classes import target classes. We have to define our project root and our YAML. So let's copy that once again. We need another one. We need the processed, where we have our process data. Process is what? Project root. Then we have data, and we have what? Processed. Okay, so we also need to have our output YAML file that we're about to create, which is our project root, and our dataset.yaml, which is what we want. So we don't have to define our main. So for split in train test validation, no validation according to YOLO, we then say image directory is equal to processed, then split for that part. Yeah, then images. So let's also have a check for when if the image directory does not exist. Sorry, if not image directory dot exists, or if there is nothing in there, not any in what? Image directory dot iter directory. So we then say print warning image directory is empty or missing. So we then have to define our YAML to say okay, according to the way YOLO wants you to structure a YAML file. So we have to do this. The path is what? Processed the resolve, then we have our train, which is train images. We have our validation, which is validation images. We also have our test, which is test images. We also have our number of classes, which is NC according to YOLO documentation, is len of our target classes. So we need to also have our names of our classes as target classes. Okay, so we can then write to our YAML file with open out YAML in writing mode as f, then do what? YAML.dump our data, then f, then default, this is default flow style is equal to false, sort keys is equal to false, and then let's print it. Print dataset written to YAML out or out YAML, and then let's print our CFG. Print CFG if name equals main, then let's call our main function. So let's run our generate YAML. Let's see that we have it generated. Okay, so where is it? Let's see where we have it. The project root dataset.yaml. So can you see it? This is our process. So our next thing, in our next video, we also have it printed here. In our next video, we are going to be training our model, and after which we then proceed to other videos for deploying, containerizing, deploying, building an inference pipeline, and so on and so forth. So